Good day and welcome everyone. This is your lecturer Ahmed Zuhaidi, and I'm going to be with you in the 48663 for the semester of the autumn 2020. Going to be your lecturer and the subject coordinator for the subject for the next 14 weeks. Now I said 14 weeks because actually we have officially 11 weeks, but from my side again to take this week and the last week as an introduction and then a revision lecture. So I sent you this email earlier for the welcome message, and I'm going to go through the Blackboard for a while, UTS Online Blackboard, and we're going to see what we have there, and after that we're going to talk about the subject outlines, and we're going to discuss about the we're going to have an introduction about the advanced manufacturing in general. So first we go through this welcome message. We have the subject outlines available on the Blackboard. As you can see here, we have to open that. Okay, so this is our subject outline. If you have any problem with the subject outline, or we may need to do any changes to the subject outline, we are going to have actually a problem because I cannot change the subject outline we have here because it's always done by the university itself. So I don't want to take you through all these talk, but we're going to go through this one in this slide. So we shall go briefly about this one. For example, what are the objective of this subject, and what the course learning outcomes. You can find all there. Don't want to waste your time. I just try to make it as short as possible. So I will go directly to the content or the topic we're going to cover here, because this will be the most important thing for us. I would like to tell you that this subject, though we're going to have some theoretical thing and do some calculations, but I just try to reduce this thing as much as possible. So you're only going to face the theoretical things in maybe less than 3 times. The assignment number 2, the assignment number assignment number 3, and assignment number 5, and then the final exam. But even the theoretical things are going to be based on the practical things we're going to do through the subjects. So we're going to learn about the quality management and the tools for quality management methodology in the metrology and tolerances and the CMM. Then that's what we're going to start to learn in the week 3 and 4 in the metrology lab. We are going to start starting from this week actually, talking about the computer-aided manufacturing and the numerical control of the machine tools, computer-aided processing, programming, and industrial robotics. Also, we're going to try to learn about 3D scanning, the additive manufacturing, and the robot prototyping. I hope that we're going to have the chance to use the 3D scanner to duplicate the parts you are going to machine during the CNC machining process. We are going to have a brief look about the PLC. We are going to talk about the flexible manufacturing systems, computer integrated manufacturing, and we are going to talk about the production planning and control ideas, like for example the just-in-time, the Toyota manufacturing system, the Kanban, and the group technology. So before I get to go through the program delivery plan, let's go through the other things we have in the Blackboard. So you will find the announcements going to appear in this section, and also I always going to send it to you as an email. I will use this option. I think that the email has been sent earlier regarding the metrology lab, and you have to do the health and safety induction before we go to the lab in week 3. So my advice is try to check that. Try to check this email, announcement. I'll try to get you more information about that, on how to do the metrology safety induction. You've been in the metrology lab before, you know where it is. It's actually going to be in building 1 level 2, and we're going to meet there together for at least 3 times a week. We're supposed to have 4 times, but I'm going to delete one of the sessions because most of the student has been enrolled into the sessions 2, 3, and 4. So Please welcome us once again. I'm going to update you each time I'm going to upload the lecture video or any supporting videos. You are going to have a notification coming directly to your email, and then you can follow up with me. So even for the student who already still overseas due to the travel restrictions due to the coronavirus, you can follow up for the first few weeks through the UTS Online and also YouTube, and I even created a WeChat account, so I'm going to put the video on everywhere, so you're going to be access to it. Now the learning materials, okay, so the lecture is going to show up in this folder. Okay, so this is the introduction lecture, the one I'm introduced to you right now, and all the lecture will appear every week in this section. Actually, it's going to be every before the class, so you're going to have enough time to go through it. Other material, for example, like the Z table, we're going to use that in the assignment number 3. Will show up here. We have something here about the workspace, which is the app client, where you can find simply your SolidWorks, for example, and the other CAD/CAM facilities. The assessment will show up here. The assessment 1 to 5 will show up here. The learning materials. Okay, now this is, we talked about this one, and the recorded lectures. Okay. Well, I followed up the. I tried to do the lecture pre-class preparation, but I stopped doing that because actually it's taking the student away from the what we're supposed to have. Here you can have the recording for the previous semester introduction lecture. I will update this one tonight. We have discussion board if you would like to have that, but actually what's happening that I prefer to go through the Facebook, because actually everybody is using the Facebook. It's much easier for us to follow up the updates from there rather than try to log into the UTS Online and try to find the discussion. Now the assessment submission. Now you can see that here because I'm the subject coordinator, so I can see the submission file folders for only 1, 3, and 5 because I put that on the student mode. But if I get to unlock that, you will see that we have the 5 assessments, 1, 2, 3, 4, and 5, plus another 2 assessment folders, like the assessment number 1 CAD model and the assessment number 3 Excel sheet. Now you need to submit these 5 assessments. Okay, these will be optional things. It's not going to be marked. So what's happened? Why when I click the edit mode off, I can only see 3, because the other assessments are actually group assessments. So for the group assessment, you should join a group, and then you will be able to see the submission link. Definitely I'm going to update the due date for this one and to match the dates we have for for this semester. Now for the groups we're talking about, these are the groups we have. Okay, so first these are the lab. Lab 1 is going to be the metrology lab, and the lab 2 is going to be any other labs which is going to be run in the building number 10. Okay, so you need to enroll in one of these groups in order to attend the lab sessions. But for the assignments, we have an extra group. For example, this is for the major project. I think that the number of the group members is not going to be more than 5 maximum. To see the submission link, you need to enroll in these groups. So before you are going to put yourself in any group, you have to discuss that with your colleagues. So all the group members are going to be in the same group, because you only need to do a single submission, and I only need to do a single marking for the submission, and the grade is going to be for the whole group members. So this for the major project. We have also for the metrology lab, and we have for the robotics assessment. Okay, I'm going to delete the robotic assessment because the major project is going to replace the robotic assessment, and as well as, okay, now these are the only two assessment we have. We have two group assessment. We're going to go through the discussion of this one soon. Later communication, the staff information. What do we have here? Dr. Ben Holken, actually he's not the coordinator. Ahmed Zuwaidi is the coordinator, myself, but actually try to avoid sending him an emails because he don't want to involve in this subject now, because he's doing another work and he will be so busy to do that. So just respect his privacy. Okay, and of course we have the other components like the control panel, the subject tool. You don't have to go through this one. We have the gray center and the other stuff. I don't want to show you that because maybe some students don't want to show their names online. So I will go through the introduction slide, and we're going to start talking about the subject once again. So as the subject outline mentioned, that this is 6 points, 6 credit point subject. You know, this is an elective subject, but it usually used to be a good subject because the student like the knowledge, the amount of the knowledge they got in this subject. The requestees are the mechanical design 2 and the manufacturing engineering, and I think that you did both. We go about the subject description. So the subject will enable students to understand the key aspect of manufacturing in modern environments, and also again to learn about the consideration relating to the volume, capital investment, the modern concept of the quality management and the quality control. We are going to learn about the modern metrology equipment and the method going to be taught to you. The student in this subject become conversant with the aspects of the computer systems and the software in relation to the modern manufacturing, and you are going to gain experiences with the CAD/CAM, CNC machining, and so on. Also, again, to able to investigate some of the roles of the industrial robots in the fabrication, welding, and the assembly process. So the plan we have for this subject in this semester, this is the week 0. Now week 0, because it's going to be the introduction session. We don't have any real class, and it's going to start by the 2nd of March. We just started 2 days ago, where we're going to have an online introductory video. We're going to have introduction about the production systems, the automation in production systems, and the automation principle and the strategies. Now, starting from the week number 1, we're going to talk about the CNC, which comes to numerical control, the numerical control process of the machine tools, the computer-aided manufacturing system, or what we know as a CAM. Also, we're going to talk about the open and closed and loop, open and the closed loop control. We're going to talk about the sensors and the actuators we're using in the numerical control system. In the week number 2, we are going to continue talking about the CNC and the CAM, or what known as the computer numerical control or the computer-aided manufacturing systems. We are going to talk about the bolt screw, the encoders, the analysis of the CNC positioning systems, and we are going to learn about the G-coding. For the G-coding, I'm going to send another video, which is going to be separate from the lecture, where you are going to learn the principles of the G-coding and how to make the G-code, how to write their G-coding manually, because this will be a part of your assessment number 1. On the 23rd of March, or well, this is Monday, the first day of the week number 3. Okay, we're going to talk about the metrology, the instrumentation, geometric tolerances, and the CMM, which is computer measurement system. Okay, in week number 4, we're going to talk about the quality in manufacturing, the statistical process control, Taguchi methods. We're going to talk about the standards like the ISO 9000, and we're going to talk about the online and the offline quality control. we're going to continue doing the same topic in the week number 5. In week number 6, we're going to learn about the robotic manufacturing, the industrial robotics, the robots control systems, and so on. This QVAC is going to be on 20th of April, and for the week number 7, we're going to go with the product design, the CAD and design manufacturing, which is the DFM, the engineering design process, and consideration of the manufacturability. In week number 8, we are going to have the topic of the manufacturing system for the single station to the flexible manufacturing systems, or the FMS. We're going to cover some of the automation technologies, the computer-aided process planning, and so on. The computer integrated manufacturing, or the CIM, is going to be covered in week number 9. And the week number 10, we're going to talk about the PLCs. In the week number 11, we're going to talk about the production planning and the control, the just-in-time and the group technology. And on the week number 12, we're going to have an introduction to Industry 4.0. And this QVAC, the 8th of June, we're going to have a review revision lecture, which is going to be non-compulsory attendance for the students. But actually, the revision format, the revision is going to cover the final exam format and the style of the question we're going to have. And I can tell you that the student who attend this revision lecture usually get very high mark in the final exam. Now let's have an introduction about the advanced manufacturing. It's something similar to the manufacturing we had, but we're going to talk about more advanced issues. I'm not going to cover the advanced manufacturing processes, but I'm going to talk about the advanced manufacturing styles and applications. So you can see that we're going to cover something like the management of the things. We're going to talk about the how to make a model and then manufacture it. So it's something more advanced than the manufacturing processes themselves. We're talking about the application rather than the technologies. So the section we're going to cover for the day is going to be about the manufacturing production systems. Also, we're going to talk about the automation and production systems. We're going to cover the manual labor in the production system role, and we're going to talk about the automation principles and strategies. So what the definition of the production system is? Simply a collection of people, equipment, and the procedure organized to accomplish the manufacturing operation of a company. So you know that we learned some previously, for example, about the casting. We talked about the machining. We talked about the additive manufacturing and other stuff. We talked about in the machining. We talked about the milling, the drilling, and so on. And we know that we have something called the material handling system, which is going to be a system that moves the parts between the machines according to the accomplishing time. So all these things are going to be an equipment. We need the people to programming, monitoring, or even involved in the manufacturing process itself. And we need a procedure to be done in these equipments. The organization of these three parts, three elements actually, is going to be the production system itself. So we have two categories for that. We have the facilities, or the factory and the equipments in the facilities, and the way that the facility is going to be organized, or what we call the plant layout. Also, it can be categorized as the manufacturing support systems, where the procedures used by the company to manage the production and to solve the technical and logistic problems in ordering the materials, moving the work through the factory, and ensuring that the products are going to meet the quality standards. So we can simply sketching that as a block diagram. So as you can see here, the production system is going to be classified as facilities and manufacturing support system. The facilities is everything regarding the manufacturing system, and the factory and the plant layout. For the manufacturing support system, is going to be the process of the product design, the manufacturing planning, the manufacturing control, and the business functions. The production system facilities are including the factory, the production machines, and the tooling. Of course, between the machines we need to have a material handling equipment. For the products, we are going to need an inspection equipment, and we need a computer system that controls the whole manufacturing operation. The plant layout is the way that the equipment is going to be physically arranged in the factory. For example, we can make it as a full cell, where it's going to have the, for example, turning, milling, and drilling operations in the same cell, and the parts are going to move between these operations until we're going to have the final part. Some places we are going to have it as separate method, where we're going to have the things instead of having a cell, we're going to have it in line, or we can have it as different department, and the parts need to move between different departments until we finish in the manufacturing process. The manufacturing systems is a logical groupings of the equipments and the workers in the factory, which can be made as a production line or simply as standalone workstations and workers. The manufacturing system, we have three categories in terms of the human participation in the process performed by the manufacturing systems. And these are three categories are: first, the manual work system, where we're going to have one worker who's going to do all the work for one or more tasks without the aid of the power tools, but sometimes he's going to use some hand tools. So just imagine there's a person who working in an Apple factory, and he need to assemble the mobile phone. So actually he doesn't have any power tools, but sometimes he's going to use the hand tools like the screwdriver and other stuff. The other type is going to be the worker and the machine system, where the worker is going to be operating a powered equipment. It can be a drill, it can be a milling machine, or it can be a drilling machine, turning machine. The third manufacturing system we have is the automated system. The whole process is going to be performed by the machine without direct principal participation of the human, but we need a human to program this machine or given to supervise the machine during the process. But he's not going to do the manufacturing process by hand like what we had in the manual turning machine, for example, in the work machine system. So in the first case, we can simply sketch it as hand tools with the worker to have the process. In the second case, where we're going to have the worker and the machine, both must be involved to have the process performance. In the third type, the fully automated systems, we're going to have fully automated machine. And the hash line shows us that the periodic worker attention is going to be required for both supervision, programming or reprogramming, or to fix the troubleshooting. The manufacturing support systems are involving the sequence of the activities that consists of four of the functions as the business function, where we're going to talk about the sales, the marketing, order entry, the cost accounting, and the customer billing. So it's what we call it the white mix, or white collar. The product design is involving the research and development, the design engineering, and the prototype shop. For the manufacturing planning is the process of the planning, production planning, the MRP, and the capacity planning. And for the manufacturing control, like the shop floor control, the inventory control, and the quality control. So the sequence of the information processing activities in manufacturing firms is going to be shown by this flow diagram. So we are going to we need to order the order to produce. We're not going to do anything without being ordered to do the things. So the business function is going to do all the processes required to decide what will be the material required for the manufacturing, what will be the cost of manufacturing, and so on. They are going to send that to the product design if the process is going to be feasible for manufacturing. The product design is going to work within the budget of the vendors and the client, and then we're going to start the manufacturing planning process. We have to send the data to the manufacturing control system, and this will be sent to the factory operation, and we need the starting material which has been ordered by the business function before we're going to start to do the manufacturing process. Now, why manufacturing control is always going to have a feedback from the factory operation? That's mean because we are going to have the continuous quality control for the produced part and aligning the process to match with the designed product. And then we are going to produce the products to the customer. Now, what the role of the automation in production systems? We have two categories of the automation in the production system, which are first, the automation of manufacturing systems in the factory, or the computerizations of the manufacturing support systems. The two categories are usually overlap because the manufacturing support systems are connected to the factory manufacturing systems. And the overlap is always going to be controlled by something called the Computer Integrated Manufacturing Process, or the CIM. So the production system, as we mentioned once again, is going to be extended to have the automation which can control the facilities and manufacturing support system through using the CIM techniques. So the automation will be enrolling a role to control manufacturing systems. But the computerization is going to be contacting to control all the other aspects like the factory and the plant layout, the product design, the manufacturing planning, manufacturing control, and the business function. Some example of the automated manufacturing systems are the automated machine tools. We have the transfer lines, we have automated assembly systems, the industrial robot that perform the processing or the assembly operations, and the automated material handling and the storage system to integrate the manufacturing operations. And lastly, we are going to have the automatic inspection systems for the quality control. So the automated manufacturing system have three basic types, which can be the fixed automation, we have the programmable automation, and we have the flexible automation. Now, an example of the flexible automation is if I get to have any machine which is limited to make a certain type of product without, actually it's going to be almost fixed, it's going to be very hard to change the product type we make on this process. That's what we call the fixed automation. If I get to have a CNC machine, we can reprogram the product continuously. So we're going to have programmable automation. The flexible automation is going to be more advanced than that, where we can simply changing the manufacturing the product type without need to do a setup time for that. That's when we're going to have more advanced computer, which is going to contain multiple programs where we can do the work alternatively for the different products. So we don't have to make a new setup for the products. We can simply change the product type with changing the program only. So for the fixed automation is a manufacturing system in which the sequence of the processing or the assembly process operation is going to be fixed by the equipment configuration. And typical features first is going to be suited for the high production quantities. It has high initial investment for the custom engineering equipment. It can have a high production rates, and it can do a relatively inflexible in accommodating the product variety. So let's think about that for a certain example. I think I have an example on the other side. No, I don't have this one now. So actually, an example for the fixed automation system, just imagine that you have a machine. Let's say it's the plastic injection molding. So actually the mold itself, we're spending something about $100,000 to make mold, and this mold cannot simply change the type of the product it's made. I know the machine itself, I mean the plastic melting machine can be simply make a multiple product, but this will depend on the mold we're going to add in the beginning. So we're investing a high cost on the mold itself, but it can only make one product. We cannot change the type of the product we're going to make. Now, for the programmable automation, it's a manufacturing system that designed with the capability to change the sequence of the operations to accommodate the different product configurations. the typical features for that, once again, is going to be a high investment in the general purpose equipment, simply because the technology is going to be too costly. This one, because we are going to need to do the changing in the products or the programming, this will have lower production rate than the fixed automation. The flexibility to deal with the variation and change of the production configuration are going to be available. It's most suitable in this case for the patch production. Now, the patch production, that's mean going to stop the whole factory, start to work for the whole week producing the product number 1, and then for the next week I need to make a new setup and start to manufacture the next, let's say, 10,000 pieces for the next patch or next product, and so on. The problem we have is the physical setup and the part of programming must be changed between the jobs or the patches we have. Now, the flexible automation is mixing between both. So it's an extension of the programmable automation in which the system is going to be capable of changing over the one job to the next job, but we're not going to lose any time between the jobs. That means that the fixture mainly is going to be mixed between the different products. The typical features in this case, we're going to have high investment for the custom engineering systems. We're going to have a continuous production of the variable mixes of the products. Now, just imagine what do we mean by the continuous production of the variable mixes of the products. If we're going to use the same raw material shape, okay, so it's going to be, for example, a cylindrical part with let's say 20 millimeter 20 millimeter diameter, and we're going to use the same raw material to make 5 different parts. It can be 5 different total different parts. So the same machine, the same turning machine, is only going to change the program to make a different part, and this can be alternatively. So if I get to have 5 parts, we can make A, B, C, D, E parts first, then we can make the A, C, D, F, E, and so on. So we're only changing the program during the manufacturing process, and thus we're going to have a different type mixes of products. So in this case, it's going to have a medium production rate, and the flexibility usually to deal with the source product variety. So if I'm going to have that as a sketch, we can see that the product variety is going to be increased if I'm going to have programmable automation, and the production quantity is going to be reduced if I'm going to have the flexible automation, while in the fixed automation we're going to have the minimum production variety, because it's going to be fixed to the first investment of the mold we made, for example. But because the programmable automation is going to have a waiting time when we change the program, and the fixtures is going to have the lower production quantity, while the flexible automation is going to be in between, because simply no waiting time for changing the fixtures, and the changing of the program is going to be within the matter of minutes. So it's going to be stand in the middle. But for the fixed automation, is going to be in the range of more than 12,000 to 1.5 million. So it's going to be the massive production rate, because simply just imagine once again the example we had for the plastic injection molding. So each time we can fill the mold and have 20 to 25 or even 50 parts to be manufactured in the matter of 60 seconds. Now, for the computerized manufacturing support systems, the objective of the automating of the manufacturing support systems are: first, we need to reduce the manual and the clerical efforts in the product design, where we're going to have reduction in the manufacturing planning and the control, and reduction in the business functions. Also, it's going to integrate the computer-aided design and the computer-aided manufacturing in the what we call the CAD/CAM. The CIM, okay, will include both the CAD/CAM and the business functions in the firm. So the CIM is computer integrated manufacturing, so it's going to mix all the manufacturing design and manufacturing with the business functions in one big system. Now, why we need the automating? First, we are going to increase the labor productivity. Second, we are going to reduce the labor cost. We are going to mitigate the efforts for the labor shortages. We are going to reduce or remove the routine manual and the clerical tasks. We are going to improve the worker safety. We are going to improve the product quality. We are going to reduce manufacturing lead time, and we are going to accomplish what cannot be done manually, and we are going to avoid the high cost of not automating. And we need to ask ourselves now, what will be the manual labor in production system role? Because we don't want to have a full automated manufacturing that making the manual labor simply to disappear. So first we need to understand what the manual labor role in the production system. So is there any place for the manual labor in the modern production system? The answer is going to be yes. So we are going to have two aspects for the manual labors in the advanced manufacturing systems. The manual labor in the factory operation and the manual labor in the manufacturing support systems. So what will be the role of the manual labors in the factory operation? Usually long term, its trend is toward the greater use of the automated manufacturing systems to subsidize for the manual labor. So when the manual labor are going to be justified? Some of the countries have a very low labor rates and automation cannot be justified. Now you're thinking about that, right? Yep. So when we're going to talk about most of the third world countries, for example, usually manufacturing of the clothes we're wearing or the other stuff is usually going to be transformed to these countries. I don't want to mention any names of the countries, but actually that's what's happened because of the low rates of the manual labors. So it's justified that use the manual labors instead of using the machine to do the manufacturing processes. Also, the task is going to be technology too difficult to automate it. Now, you may imagine that till today, most of the mobile phones assembly processes, or at least 80% of the assembly processes, is done by the manual labors. Because when we dealing with a very small critical parts, it's very hard and difficult to automate the process. Also, if we're going to have short product life cycle. Now, I don't want to invest in a simple manufacturing system, for example. We're talking about the tractor. Okay, tractor assembly process. We're not going to manufacture millions of tractors. It's going to be in the range of less than 5,000, for example. So I don't have to heavily invest in an equipment that automating the assembly process of the tractors. So the manual labor simply can do the job. Also, for some of the customized products that require human flexibility, like what we call the handmade things, watches or the very high luxury car, which are assembled by the human, and some of the parts which need to have some human skills to do the work. Also, to cope with the up and down in the demand. So if I'm going to have manual labors, that doesn't mean I don't have to stop my machines from working when I don't have demands. I'm going to have a labor, but they're going to justify their payments while they do the work, and they're going to be on vacation when they don't have a demand for the work. Also, is to reduce the risk of the new product failure. So I can start to do the work and manufacturing process for a certain product without investing in the machines. Just check what happened after a few months. If the product is going to be succeed, then I will start to do the investment in the new product for the automation. If not, just simply close the factory and release the workers. What the role of the labors in the manufacturing support systems? We know that the product designers who bring the creativity to design tasks are human. the manufacturing engineers who are going to design the production equipment and the tooling, and plan the production methods and the routing. And the equipment maintenance process always done by the labor, and the programming and the computer operation is always performed by the human labor. The engineering project work and the plant management process. The principles and the strategy we have for the automations are, we have what we call the USA principle, and we have the 10 strategies for the automation and the process improvements, and we have the automation migration strategy. So what is the USA principle? Is to understand the existing processes, like what are the input output analysis, what the value of the chain analysis, and charting techniques and the mathematical modeling. Second, simplify the process as much as possible. That means we are going to reduce unnecessary steps and moves. Third, automate the process. And in this case, we are going to use the 10 strategies for automation and production systems, or using the automation migration strategy. So what are the 10 strategies for the automation and the process improvements? First, we need specialization of the operations. We need to combine the operations together. We need to simultaneous the operations. We need the integration of the operations, increase the flexibility, improve the material handling and the storage, and we need to use the online inspection, and we need to do the process control and optimization, do the plant operations control, and finally we need to use the computer integrated manufacturing as much as we can. The automation migration strategy for the introduction of the new products are, we need first to, we have the phase number 1, which is going to be the manual production, where we're going to use the single station manned cells working independently, and the advantage of that is going to have a quick to set up and low cost of the tooling. The phase number 2 is the automated production, where we're going to have a single station automated cell and operating independently. As demand is going to grow and the automation can be justified. The phase number 3 is going to be the automated integrated production. Well, if the demand is grow and we have the good success for the product, simply we can go for the multi-station system with the serial of the operation and the automated transfer of the work unit between the stations. So this will be the automation migration strategy. The phase number 1, as you can see at the top part, is going to be simply the manual workstations, and even the material handling is going to be manual handling. So for the phase number 2, we're going to have the manual handling between the automated cells. And thus, as we mentioned once again, every automated cell is going to do the work of the manual workstation, but with high efficient, high accuracy, and of course more production rate. And that's what we can see here for the one station cell on the phase number 2, where the product demand is going to be increased. We're going to have to use the phase number 2. If the product demand has been increased further, we're going to jump to the stage number 3. We're going to cut the time we're wasting during the manufacturing process in the phase number 2 due to the manual handling by using the automated transfer work unit or the automated material handling system. So for the technological categories of the production system, we can simply classify it into 2 levels. The first top level is called the enterprise level, where it's going to contain the manufacturing support system, the business aspect, and the design aspect. The quality control system is standing in between the enterprise level and the factory level, because simply it's going to get the data from the manufacturing system and send it to the manufacturing support system in case if we need to make any changes to the manufacturing operation. At the factory level, we're going to have first the manufacturing systems, which is going to get the data from the automation and the control technologies, and the material handling and identification process. And this will simply going to control the manufacturing operations toward getting the final products. So you can see that the arrow show you which part is going to have the feedback and which part is going to send the data for the operation process. So I don't want to take long time from you for this introduction section, so we're going to end up here and hope to see you on the first lecture in week number 1. Thank you very much for your time and see you next week.